Hello there guys, welcome to my channel. Okay, in this video I'm going to explain to you about the physics paper 4, 42, October, November 2021, and the time duration here is given 1 hour and 15 minutes. Okay, now let us move on with the first question. Okay, first question. Figure 1.1 shows a space rocket accelerating away from a launch pad. Okay, now Figure 1.2 is a speed time graph for the first 30 seconds of the rocket's flight. Okay, here's the speed and here's the time. Okay, we can see it is accelerating. Alright, you can see it's accelerating here. And this graph can be divided into two parts where if you notice from here, at the 10th second, 0 to 10 seconds, right, they will have a uniform acceleration. It means a constant acceleration, the same acceleration here. And 10 to 30 seconds, you can see the acceleration is actually gradually increasing. Okay, now we answer the first question. Look at the first question here. Okay, describe how the acceleration of the rocket change between the 10 seconds and the time 30 seconds. As I mentioned to you, they will have an increasing acceleration. Alright, this is your answer. Increasing acceleration. Okay, this is 1 mark. Okay, now move on with the next question. Okay, by drawing a tangent to the graph, determine the acceleration of the rocket at time 25 seconds. Okay, now we look back at the graph. Okay, 25 seconds. So let me erase this. Okay, at the time 25. So here it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Here's 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and here's about 20 boxes. Alright, 20 boxes. So the value is 10. So 10 divided by 20 boxes. Each they have about 0.5 value. So if you want 25, so it should be about 10 boxes, half. So we calculate again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is 10, which means this is 25. Okay, this is about 25. Now we look above the graph. So here I just make a small line over here to determine straight. So this point is a 25. Alright, this point is a 25. Oops. Okay, now we go back to the normal shape. Okay, now we have to draw the tangent line from here. So we can use let's say a green color. So we must draw a tangent line. So make sure it is touching it only at one point over here. It's close enough. Okay, so this is the tangent line. Not that accurate. Okay, it's almost here. So now it's up to us where we want to choose. Okay, let's say I choose this point. And before that, let us confirm back the position over here. So here's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So each point they have about 50. So each is 50. Okay, each is 50, and we confirm the coordinates. So here we do have, in this point is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So here should be 5. This is 6. This is 7. And this is 8. Alright, this is 8. And then we calculate here. So this point should be, I'm taking this coordinate here. So this is about this is 1600. This is 1600, 700. So this is 1750. Okay, so I'm taking the coordinate 1750 to 0, this range, and I'm also taking the range of 30 to 8. So all you can do here is to find the gradient, we have to divide the y divided with the x, right? Y divided with the x. So here we have 1750 divided with 22. So let us calculate this. So I'm getting here about 79.54. So you can bring this calculation to the here. So 1750 divided by 22, you are getting here about 79.5. So this is your acceleration, meter per second square. Okay, now see, determine the distance traveled by the rocket between 0 to the time 10 seconds. So here can be done by using this formula. Velocity is distance over the time, right? So we have to calculate the area in order to find the distance. Velocity times with the time. So which means the area under the curve, under the graph. Okay, area under the graph. So now go back to the graph. Here. Okay. So we can erase this. And we just take this part. Okay, now we need to determine the value here for this point. So which is, we make it bigger. Okay, this is about, which is here. So it's like 100, 200, 300, and here's about 400. Alright, so the height here is about 400, and here's about 10. So that we have to calculate the area of this triangle. So remember this 410. So now 1 over 2 times 400 times with 10. All here we are getting is about 2000 meter. Alright, so this is your distance. So total marks for the first question is about 5 marks. Okay, then we move on with the second question. Okay, state Hooke's law. This is a spring question. 2a, state Hooke's law. So Hooke's law, please remember the formula. F equals to kx. F is the force. This is your extension. Okay, extension must be in meter form normally. And the k value is your spring constant. Like how strong is the spring. If it's easily easily being pulled or compressed is a low value of the spring constant. If it's a very strong spring, it has a very high value of the spring constant. So we can write it down. Okay, let me type it for you. Okay guys, so this is my answer here. Okay, the extension of the spring is directly proportional to the load, but limited to its elastic limit. All right. So okay, now let us move on with the next question here. Okay, B shows figure 2.1 shows the extension load graph for a spring. Okay, this is the extension and this is the load. As you can see here, okay, this is much more clearer. Okay, until at this point, right? Until at this point, you have a steadily proportional, the force and the extension. After this point, which means it's already exceed its elastic limit. Okay, so it's no more proportional. So now we go back to the question. Okay, on figure 2.1, mark and label the region where the spring obeys the Hooke's law. So now let us calculate the value here. So here they have about 20 boxes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here the definitely is 25. And here is about 21, 2, 3, and 4. Here's 26, 7, 8, 9. Okay, now we go back to the graph. So, okay. Now we go back to the graph here. Okay. Now, okay, mark and label the region where the spring obeys Hooke's law. So it means that you can label anywhere between, okay, between the 0 to 20.5 over here. Anywhere you can label it, maybe here or maybe here or maybe here until at this point. All right. Okay, now the second question here, calculate the spring constant K value. So K value, for the K value, I'm going to erase all of this and we are going to calculate using okay, now before that, let us determine the value of these boxes. So here we have about 20 box, I guess. So it's like 10, 20, 30, 40, 50, 60, 70, 80. Oops. Oh, here I did wrong at this part. 30, 40, 50, 60, 70, 80, 90. And here at this point, okay, this is better. Okay, we will see where exactly the 20 is going. 20 is not a beautiful point, so we can get somewhere over here, which is more better. Okay, so we just take this point. So this is 19. Alright, 19. And this point here, I'm just going to use the indicator. Alright, this point. So we have here 110, 120, 130. Here's 1, 3, 5. Okay, so here, this point here is about 1, 3, 5. The height over here. And this one here will be up to 19. value is 19. So we are going to use both of these value to determine the spring constant. Okay, so here we have, okay, to determine the spring constant. So here we will have force over the extension. Alright, force over the extension. So force here is 19 Newton divided by 135, and take note that this is mm. Alright, so this is a millimeter, so you need to times with 10 to power of negative 3. So please take note of this. So the calculation here will be, so I'm getting here about 140.74. Alright, so this is a Newton per meter. So this is your answer, guys. Newton per meter. And okay, the original length of the spring is 120 millimeter. Calculate the length of the spring when a load of 8.5 Newton is applied to the spring. So we can use the value of this spring constant to determine the extension. So here we can use the same formula given, and here's about 8.5, and here the spring constant is 140.74. You need to calculate the extension. So the extension is calculated by 8.5 divided with the 140.74. So your value here will be you have a 0.06. Okay, 0.06 meter. So you have to change it into millimeter. So change it to a millimeter, multiply with 1000. So here you are getting about 60 millimeter. So this is only your extension. Okay, so remember this, and you have to plus with your original length to determine the length of the spring. So 60 plus with 120 mm. So here we have about 180 millimeter. This is 2 marks. Okay, now we move on with the next question. Okay, the weight of an object is 4 Newton on a planet where the acceleration of free fall is 8.7. So calculate the mass of the object. So here we can use weight equals to mass times gravitational acceleration. So 4 equals to mass multiply with 8.7. So we just have to divide this, and we are dividing this, and we will be getting here 4 divided by 8.7. We're getting here about 0.45977, so which is about 0.46 kg. Alright, 0.46 kg. So take note, the value is 1 mark and the unit is 1 mark. Alright, so make sure you write the unit here. So this is 2 marks. Total mark for this question is about 8 marks. Okay, we move on with the next question. Okay, picture 3. Okay, 3.1 shows a collision at a very slow speed between two cars traveling along a straight road. Should be a traffic jam here. Okay, now car A, and then you have a car B. Okay, now car B, mass of 800 kg, moving at 2 meter per second, collides with car A of mass of 1000 kg, which is stationary. Okay, this is at rest. So after the collision, both cars travel in the same direction as the initial direction of B. So this is inelastic. Okay, this is an inelastic momentum. So after the collision, the car moves at 1.3 meter per second. So show the speed of the car B after collision is approximately, wait a minute, okay, this is a bit confusing. So after the collision, both cars travel in the same direction. Oh, sorry, they have a same direction. Same direction. So it is not an inelastic collision, it's an elastic collision. So here after the collision, they move separately, but they are not sticking together. Yeah. So we have to use this formula m1u1 plus m2u2. I can say this is equals to m1v1 is the speed after the collision. Okay. So here, so I'm just going to key in the values. So here we have about 800. Maybe I can change it to, here's the B, here's the A, and here's the B, and here's the A. Okay, so here we will have a 2, and since the A is a stationary, so we can put here 0. Okay, so the B is 800. So I'm not sure about the speed. Alright, so we just put there V, and here will be about 1000, and it is moving at the 1.3. Okay, now remember momentum before and after should be the same. Okay, then here will be 0, right? So here's about 1600, so it's about 800 V, and here's about 1300. Okay, and then this one will move here, it becomes 300. So to get the velocity of the car B, so here we have about 300 divided with the 800, and you'll be getting about 0.375, which you can round it off to 0.4 meter per second. Okay, so you have shown the speed of the car B after the collision is about 0.4. Alright, okay, now this is the momentum. So calculate the impulse exerted by car A on B. So as you know, this impulse you can, from this formula, okay, mv minus mu. So exerted by car A. So what is the final velocity of car A? You have to use this value. Okay, this is from the A, and this is from the early A. This is the U, right? So this is the V. So this is about 1300 minus 0. So you'll be getting here about 1300. And here we have kg meter per second. Okay, now state the impulse exerted by car B on A. So now the same thing here. So I'm going to use a blue color as the indicator. So it should be the same. Okay, the same with this previous answer. Example. Okay, this is your U, right? So here will be about 1600, and the final 0.4 multiply with 800. We are going to use this. So you got there about 3200. wrongly multiplied. So here should be about 320. So but the actual value here supposed to be 800 times with a 0.35375. Okay, so the value here supposed to be about 300. So I just make a round off here, 300. So here is about 1000, negative 1300. So this is the proof is the same. All right. So you must have the same answer here. Okay. So this is a total of 6 marks. So whenever you have an impulse, either one should be a positive and another one should have a negative value. But since they're just asking us to state, we just can state both it as a positive values. Okay, question number 4. A power station uses wind energy to generate electricity. State and explain whether this method of generating electricity is renewable. So you can simply say that it is renewable. So your explanation here is wind is a natural energy and can be replaced. Okay, can be replaced. So this is your answer, or you have other words that suits this explanation. Yeah, should be fine. Okay, state two energy resources that do not have the sun as their source. So you can say something like a geothermal, because this is coming from the earth, the volcano. And you can also say as nuclear. Okay, nuclear energy, this is coming from this radiation. Okay, from each energy source resources, state the form of energy stored in a fossil fuel. So fossil fuel is like a petrol, diesel, kerosene, so it is in a chemical form. So water behind the hydroelectric dam, so this is a gravitational potential energy. Okay, gravitational potential energy. Okay, the reason why, so let me just draw for you a few pictures over here. So here we will have the dam. Okay, so this is the basement of the dam, and the water will be stored over here. This is the dam, right? So when they are moving, okay, so here will be the turbine. Okay, here will be the turbine. Sorry for my bad drawing. And here will be the motor, and this is how the pressure. Okay, so the height from here to here can be about few hundred meters. So you imagine the water being stored is actually influenced by gravitational potential energy. Then it will transfer to kinetic energy to flow and turn on the turbine. So once it is started to swing, it will produce the energy here. Okay, so this is about total 6 marks for this question. So let us move on with the next one. Okay, a thermocouple thermometer is used to determine the temperature difference between mixture of ice and water and a liquid mercury, approximately about 600 degrees Celsius. Okay, complete the diagram with a label diagram to show how the thermocouple thermometer can be used in this way. So we have to draw here. So you can draw the galvanometer. Okay, then you have one metal each. Normally it is iron and copper. So the copper we can fuse over here and here. So this is called as a junction. Okay, these two parts we call it as a junction. So these two junctions you have to place it at two different temperatures. So that's how the thermocouple thermometer works. Okay, now state two other physical properties that can be used to measure the temperature. So since they are asking about physical properties, you can mention like our normal thermometer with a mercury, which is involving expansion of liquid. Okay, expansion of a liquid, and you can also play around with electrical resistance. Okay, electrical resistance. Okay, the next one. Okay, state two benefits of using thermocouple thermometer instead of a liquid in glass thermometer. So here the two benefit things you can say is you have a response quickly. Okay, you can see it's a quick response, and you can say as a smaller in size. Alright, smaller in size. So this is about 7 marks for this question. Let us move on with another one. Okay, so here number 6. 6.1 shows a particle of a material in which a sound wave is traveling. Okay, so now on a figure 6.1, mark the center of compression with the letter C. Compression, as you can see over here, the particles being compressed. So here C, and here C. Center of a rarefaction is the opposite of a compression. So we can put here the R here, R here. Okay, one wavelength with a double-ended arrow. So you can either draw it over here or you can draw here. Alright, so make sure it's exactly at the center here, at this part, or at this part. But normally they'll be taking compression. So it's 1 mark each. Okay, now circle one value from the list, which is the speed of the sound in water. So speed of the sound in water definitely is a 1500. So remember, in solid, okay, in solid, okay, let me start with the gas. Sound, okay, speed of the sound in gas or air is about 330. Water is about 1500. Solid, you will have about close to 5000. Okay, so this is the speed of sound in each of these medium. So wavelength of the sound wave is in water is given 12 centimeter. So here you have V equals to frequency times with lambda. Lambda is the wavelength. So speed is about 1500. Frequency, okay, change the wavelength into a meter form. So 0.12. So the frequency you can make it 1500 divided by 0.12. So I'm getting here about 13,000 Hertz. Okay. So state and explain whether the sound in C is an ultrasound. So okay, our human hearing range is 20 Hertz to 20,000 Hertz. 20,000 Hertz. Okay, 20,000 Hertz. So anything beyond the 20,000 Hertz is called as ultrasound. So which means this one is not an ultrasound. So you can say the statement here, this sound is not is not ultrasound. Okay, your explanation. If it's an ultrasound will have, or you can say more better, consists of, so you can write it like this: ultrasound has a frequency above 20 kilohertz. Alright, so this sound is not an ultrasound. Okay, so we move on with the next one. So total marks for this question is about 9. Okay, question number 7. 7.1 shows a ray of light approaching a face AB, okay, of a glass prism of a refractive index 1.5. Okay, and then on figure 7.1, accurately draw the path of the ray within the prism from face AB to AC. You will need to make a measurement from figure 7.1 and carry out a conclusion. So here we need to enlarge this AB to AC. Okay, so from here we need to draw the normal plane. Alright, so I just draw with a black color normal plane. This is a normal plane. So I'm going to use the protector over here. So I'm going to place this here, so which is exactly at this part. Okay, just make the changes. So you have to measure this accurately and put this line exactly here. So bear in mind that this is the eye, okay, the incident angle, and here, so whatever that is going coming from here, and this is the R. Okay, so the eye, angle of eye here, the incident angle you have about 53 degrees. Okay, 53 degrees. Okay, 53 degrees, and then we try to minimize this. So from here they mentioned that the glass prism is a 1.5, right? So we have to do the calculation here. Sine the incident angle, so which is about 53, and sine R equals to this refractive index 1.5. So here we have to divide this 53 divided by 1.5, and here is a sine R. So your answer here will be, so here you'll be getting there about 0.5324, and then we shift sine to here, right? So here you'll be getting your refractive angle, so which you'll be getting here about 32, okay, 32 degrees. So here is your calculation, 32 degrees. So now we just have to rotate this. Okay, we just have to rotate to the opposite side. So roughly is here. Then we zoom. So we need to locate 32. 32, which is around, if it's a more bigger, and take note that I'm using this electronic electronic compass, so which will not give you the exact answer as you are doing it on a piece of paper. So I'm just showing you the steps. Okay, so here you have about 32, which is slightly about here. So I just mark here. Then we can eliminate this, we can put it aside. Then we can draw a straight line from here to here. Okay, to the point that I draw, this part. Okay, so just continue. This is the normal line. So the angle here will be about 32 degrees. Okay, now, so this is the calculation here, guys. Okay, so this is the calculation, you have to show it. Alright, you have to show this calculation, and it's all depending on the angle you are getting over here. So since I'm using an electronic compass, it might be not that accurate compared to the one that you are doing it on a piece of paper. Alright, so we have done with this question. You will need to make a measurement. Alright, we have done the measurement and carry out the calculation. They're just asking us to accurately draw the path. Okay, so just put an arrow over here. Okay, now we move on with the next question. Okay, determine the angle of incidence of this ray when it strikes face AC. When it strikes the face AC. So here, so again we have to do some measurement over here. So let me pull off my digital compass. Okay, I think make it more nearer. Okay, with the same technique, you have to draw the normal line first. Alright, so we have to draw the normal line, a straight line. Okay, then we bring the compass. So I try to make it smaller. And this is smallest. Okay. So it should be the opposite way. Make it parallel to the lines. Okay, as you can see here, this is 90. Alright, this is a 90 degrees, this part, and here it goes to 100. So which means the angle here is about 10 degrees. Okay, so let me zoom out. As you can see here, so they are asking determine the angle of incidence of this ray when it strikes face AC. So which is this line, right? Okay, this line. So it's a 10 degrees. So just have to write here 10 degrees. Okay, now without further measurement or calculation, sketch figure 7.1 the approximate path of the ray after passing through the face AC. So you can draw this. Okay, now I'm going to erase this part. I'm going to erase this part. And I'm going to delete, cancel off this compass. Okay, now you draw again the straight normal line. Okay, continue again. Normal line. Okay, so this is a prism. Okay, and this is air. So here will be the more lighter density. Okay, low density, and here's a high density. So the light is traveling from high density to low density. So you should have, the angle should be more, right? So you can draw it in this way. Make sure your angle is bigger. Okay, so this is your angle. So make sure this angle here is much more bigger compared to this one. So successfully drawn. So we have done with this question. Okay, now figure 7.2 shows a ray of light traveling within the optical fiber. So complete the path of the ray of light to the left hand end of the fiber. So here what you can do, this part, here you will have a normal line. So you can draw almost with the same angle, right? Almost with the same angle. So we can draw it here, and then we draw again the normal line. We draw another one about the same. Make sure your angle is the same. Alright, so this is how. So over here we will have a total internal reflection. Total internal reflection. Okay, so normally for the optical fiber you will have two layers. So let me just explain it to you further. So normally you'll have these two layers. So this is a layer 1, okay, and in the middle you have a layer 2. So these two layers will be a much more high density. Sorry, this one will be the lower density. Okay, low density, and in between here you have a high density. This part here you have a high density. So this is how the optical fiber will operate. So we move on with the next question. Okay, figure 8.1 shows a conducting object A, initially uncharged, held on an insulating stand. The positively charged rod B is brought close to object A. Okay, now draw the distribution of charges on A. So for your understanding, it should be when the object is in neutral, right? When the object is in neutral, you must have an equivalent number of a positive and negative. Let's say I just draw here about about 8 positive, okay? 1, 2, 3, 4, 5, 6, 7, 8, and then you have negatives. So you have 1, 2, 3, 4, 5, 6, 7, 8. Alright, so you have here initially you have here about 8 electrons, negative charge, and also the 8 positive. This is just an example. Alright, so when you having a positive charge, the plate is coming. So remember, your positive charge does not move. Okay, it does not move. So only your electron will be moving. So here some of the electrons will move to the object B. So the electron will jump. So here you have negative, 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 negative. Alright, so we just have to erase the negative. So make sure you put more positive here and less negative. So now we have 8 positive, the positive remains, and then you have a 4 negative charge. Alright, so this is your explanation for both B and A, but the question is only asking about A. Okay, now a wire is connected from object A to the earth. So maybe this is like this. Okay, state and explain any movement of charge. Okay, so when you have a earth over here, this is the earth. Earth is negative charged, alright? Negative charge. So what happens is the negative charge will be coming from the earth to the object A. So it will be make it equal. So your statement here will be the negative charge. So negative charges flows from earth to object A. So your explanation, electron flows from earth to balance out. Okay, to balance the positively charged object A. Okay, so this is your explanation for this statement. Okay, now we could move on with the next question. Okay, there is a current in the wire. This is the current for 2.2 minutes. Calculate the charge that flows. So we can use this formula. Okay, this is the current equals to charge over the time. So the current here will be 0.65 milliampere. Okay, this is the charge. And make sure your time here will be in seconds. Alright. So 2.2 times with 60. So we just have to take this, multiply it over here, and you'll be getting your charge as 0.086 coulomb. Alright, so the total marks for this question is about 7 marks. Okay, so we move on with the next one. Okay, number 9. Figure 9.1 shows a cell of electromotive force 1.5 volt and a battery of EMF 6 connected in series. So calculate the combined EMF of the cell. So here is all is in the same sign. Alright, so it can be plus together to form 7.5 voltage. Okay, so now we move on with the next one. So this is a combined resistor. Okay, combined resistor of a 3 resistance. Okay, so here, so they have a combined resistance of a 4.4 ohm. So we need to solve this one first. So 1 over R total equals to 1 over 2 plus with 1 over 3. So here we have about 6, 3 plus 2. So here we have about 5 over 6, then we make it invert. Alright, we make it invert. So our total is 6 over 5, which is 1.2 ohm. Okay, and then the circuit will become like this. So this is 1.2 ohm that we have calculated, and this is the R. So your total here will be R plus 1.2 equals to with 4.4. So your resistance here will be 4.4 minus with 1.2, which will give you about 3.2 ohm. So this is your resistance of R. Okay, so I hope you can understand this calculation. Okay, we move on with the next one. Okay, current I is 0.94. Calculate the potential difference across the combined resistance. So here we can use V equals to IR. So the combined resistance is 4.4, and the current, current we can just multiply it over here. So you will get your answer. So just calculate this, both of this value, you will be getting here about 4.1 voltage. Right, so that is your answer for this. Total marks for this question is 6 marks. Okay, we move on to the next one. Okay, name the logic gate shown in a figure 10.1. So this one is definitely is your OR gate. Alright, OR gate. Don't get confused with AND gate. AND gate is supposed to have a D shape, D letter shape. Okay, this is AND gate. Okay, now for 10B we have, okay, 10.2 shows a combination of a logic gates. This is the NOT gate and this is NOR gate. Okay, it's a NOR gate because you have this is NOR gate. So in case you get confused with the NOR gate, so just remember the truth table of a OR gate. So the OR gate truth table here is AB, which is the input, is the OR gate, 0, 1, 1, 0, 0, 0, 1, 1, 0 and 1, 1. So the OR gate here you get 0, 1, 1, 1. So if you have a NOR gate, you have to make it opposite, which is 1, 0, 0, 0. So now if your input is 0 here, 0, so you should have 1. So when the line is breaking out to 2, right? So here both you have 2, 1, 1, 1 and 1. So for NOR gate, you have to look at here, NOR gate. So look at this. This is 0. So your output O is 0. So now we erase this back and we replace with 1 here. 1, right? We follow this. You'll get 0. So if you get 0, both will be 0 here. And your output O, you have 1. Okay? So this is for the first question. Okay, now an electrical device has a metal case. Explain the benefit of earthing the metal case. So one of the benefit of earthing the metal case, in case the live wire, okay, which carries the current, touches the metal case, it could prevent electrocution, and you can add on by flowing excess current to the earth. Okay, so now the D1, explain how a fuse protect a circuit. So when a current supply is higher than normal, let's say you are using about 13 ampere, let's say the current supply in the case of you have a thunderstorm, maybe it's about 15, right? So what happened, it will melt the fuse and cut the connection to the device. So the fuse normally you will have is like a thin wire, okay, the thin wire like this. So this is your the connection between the live wire. Alright, so here you have the live wire and is being connected with your device. Let's say using an Apple phone. So in the case of you have a thunderstorm, the current is like more higher, it will only cut the connection of this. So this wire will become melt and cut the connection and your device will be safe. Okay, so this is how the fuse will protect a circuit and also your device. Alright, so we move on with the next one. So number 2, the current in an electric kettle connected to a main through a fuse is 10 ampere. The fuse with the following rating are available. Circle the correct fuse rating for this appliance and explain your answer. So current in the kettle connected to the main through a fuse is 10. So it means the electric kettle is running at a 10 ampere. So you have to use a bit higher, which is about 13 ampere. Okay. So the fuse rating, so normally why we choose a higher, so the fuse rating must be must be higher than the operating current value. Alright, so this is the explanation for this. Total mark for this is about 9 marks. Okay, then we move on with the next question. Okay, number 11. Describe a composition and structure of a neutral atom, beryllium-8, which has a proton number 4 and nucleon number of 8. Describe the composition and the structure of a neutral atom. So you have to explain in words, not by drawing. So here we have a beryllium, which has a proton number of 4, and here we have a nucleon number of 8. So we have a proton 4, neutron is 4, and yeah, both of these. So what happened? We will have about 2 shells, alright, 2 shells. The electron number is 4 and your electron arrangement here will be 2.2, correct? Okay, so now your explanation here will be like this. Okay guys, so this is my suggested answer. So here you have to explain in every aspect, okay? You have to explain about the nucleus. A nucleus is surrounded by 2 shells of electron. First shell has 2 electrons and second shell has 2 electrons. There will be 4 proton and 4 neutron in its nucleus. Okay, since it is neutral, it must have a same proton and electron number. Alright, so this is your answer for 4 marks. So let me minimize this. Okay, now we move on with the next one. Okay, radioactive isotope decay by beta emission to form an isotope of barium with nucleon number of 135. Use the data from table 11.1 to write down the nuclide equation for this decay. Okay, it means that they are saying a radioactive isotope decays by beta emission to form an isotope of barium with nucleon number of 135. So if you look at the periodic table over here, look at barium. Okay, barium, they have about 13, this is nucleon number of 135, so here will be 137. Okay, 56 and 137. So please remember this, 56 and 137. So here we are going to put here the proton number will have the same, because isotope will have the same proton number, right? Same proton number. So barium is 30. How much is it? It's 56. So it's about 56. So it's about 56. And here's about 135. Okay, so now we have to find something that decays. Okay, something that decays, and you will have 135, 56 barium, and it will release beta emission is electron. Okay, so this, so they have given here. Okay, even though you did not use a periodic table, they have given here. All right, so we need to find. Okay, so the total number of a nucleon should be the same. All right, 135, and here you have to total up, and here you must get the same value. So 56 plus with negative point, here you'll be getting about 55. So from here we have to find the element that has a 55, so which is cesium. So this is your answer. So you just have to replace the cesium, the A with cesium. So this is 135 with 55, and this is your equation. Okay, so I hope you understand this and you learned something from this paper, and thank you for watching again. So if you have any question, please comment below. It will take some time for me to reply. Anyway, thank you very much and all the best, guys.